So here is another question on linear inequation. So we have to solve and graph the solution set of the first inequation, which is minus 2 lesser than 2x minus 6, or minus 2x plus 5 greater than or equal to 13, where x belongs to a set of real numbers. So if you see, we discussed a similar question where in place of or we had and, two inequations and here it is or. So the difference between and or you will see when we solve this question. Okay, so the first inequation which we have, which is, it is given by minus 2 lesser than 2x minus 6. So that implies if we take this minus 6 to the LHS, it becomes plus. So 6 minus 2 is lesser than 2x. That implies 4 is lesser than 2x. That implies 2x is greater than 4. So if we divide both sides by the same positive number, we have x greater than 2. Okay, this is the first part. Then we have minus 2x plus 5 is greater than or equal to 13. So here we take this 5 and take it to the RHS side, becomes minus. That implies minus 2x is greater than or equal to 13 minus 5, that is equal to 8. Now we have studied in the rules of handling linear inequations that if we change the sign on both sides of the inequation, then the sign of inequality gets reversed. So here if we change this minus 2x to 2x and this plus 8 to minus 8, we have changed their signs. So this greater than equal to will become lesser than equal to. Okay, the sign of inequality got reversed. Now if we divide both sides by the same positive number by 2, we have x lesser than or equal to minus 4. So this is the solution of the first inequation. This is the solution of the second inequation. Now let's just plot them separately on the number line. So for x greater than 2, let us draw the number line first. Okay, this is x greater than 2. So we have here, let's say 0, this is 1, this is 2, this is 3, this is 4, this is 5, and it goes on and on like that. Here 2, we have to mark first the point 2. Here it is a strict inequality, greater than 2. The solution should be greater than 2. So we will highlight this point 2 with a hollow circle. Okay, because it is not part of the solution. Every other real number value which is greater than 2 is part of the solution. So that is represented by a solid line which goes to the right side of 2. Okay, and goes on and on and on like that. Then for this is x greater than 2. Then we have x lesser than or equal to minus 4. Okay, so here again we'll draw a line, number line, real number line. Okay, let us draw it here. Okay, okay, so here we have, say, 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, and it goes like that. So here we have to first highlight the point minus 4. See here, lesser than or equal to minus 4. So because of this equal to sign, this minus 4, it is part of the solution. So the convention says that when it is part of the solution, when it is included in the solution, you highlight it with a solid, let's use the green ink, okay. You highlight it with a darkened circle. When it is not included, you highlight with a hollow circle. Then lesser than minus 4, equal to is done, then lesser than minus 4. So to the left of minus 4, a solid line like this. Okay, it goes on and on. Now, if we talk about this OR part, solution of this or solution of this, so we have to include, let's say we draw all of them on the same number line, so it will be a big number line. Okay, okay, so here it is, 0, this is 1, this is 2, this is 3, this is 4, 5, like that, and here we have minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, like that. So for the first part of the solution, which is this, x greater than 2, so a hollow circle and a solid line which goes to the right, like this. And then for x lesser than or equal to minus 4, minus 4 is included in the solution, so a darkened circle and a solid line which goes to the left of this. So here it is to the right of this, here to the left of minus 4, and it goes on. So this is the solution of x, let me use this pink, okay, x lesser than or equal to minus 4 or x greater than 2. Now here by chance, suppose instead of or, it would have been written and, okay, we have to solve and graph the solution of minus 2 lesser than 2x minus 6 and minus 2x plus 5 greater than or equal to 13. So here we have to find an intersection of both the solutions, values common to the solutions of both the inequation. So in that case, there would have been no solution in this case. In case of and, okay, and there would have been no solution because there is no overlapping point, no common intersection point between these two solutions. They do not meet anywhere. Okay, they do not meet anywhere. There is no overlapping point. So in case of and, here it should have been mentioned and instead of or, then there would have been no solution because there is no common values to both the solutions here. X greater than 2 and x less than or equal to minus 4, there is no common overlapping region. Okay, so this is the. So here is another question on linear inequations and one variable. So here it is given that there are two different, inequations here, P and Q. P is represented as x with the condition, the inequation 5 is lesser than 2x minus 1 lesser than or equal to 11 with x belonging to the set of real numbers. The second combined inequation, which is Q, represented as minus 1 lesser than or equal to 3 plus 4x lesser than 23 with x belonging to integers. R and I, they represent real numbers or integers. So here it is given to solve first of all we have to solve them and then we have to represent P and Q on separate number lines. And then we have to write down the elements of P intersection Q. Okay, or in a way it is the common elements to the set P and Q. There are two different sets, isn't it? P and Q. So we have to write down the common elements of P and Q. That is what this intersection means. So let's first solve them. Okay, so first is P. Okay, P, which is written as x 5 lesser than 2x minus 1 lesser than equal to 11 with x belonging to real numbers. So as you can see, this whole thing, it consists of two parts. Okay, 5 lesser than 2x minus 1, and we have 2x minus 1 lesser than equal to 11. So we have to solve them individually. So that implies here, if we take this minus 1 to the LHS side, we have 5 plus 1 lesser than 2x. That implies 6 is lesser than 2x, or we can write it as 2x is greater than 6, or dividing both sides by 2, we have x greater than 3. Okay, x greater than 3, this is the first part, and then we have 2x is lesser than equal to 11 plus 1. That implies 2x is lesser than equal to 12. Dividing both sides by the same positive number, we have x lesser than equal to 6. Okay, so we have x greater than 3, x lesser than equal to 6, or we can write this as 3 lesser than x. Same thing. So we can write the combined solution as 3 lesser than x lesser than equal to 6. So if we plot it on the number line, so we draw the number line first again, and x belongs to real numbers. Okay, this is very important. X belongs to real numbers. So if we draw the number line, okay, we have, let's say, 0, 1, 2, 3, 4, 5, 6, 7, and so on, like this. So here there are two extreme points. One is 3, the other one is 6. For 3 it is x greater than 3, a strict inequality. So 3 is not part of the solution. So when you have something which is not part of the solution, you highlight it with a hollow circle. Okay, again let me use the blue color. Okay, a hollow circle like this. Okay, a hollow circle. Then x lesser than or equal to 6. For this equal to sign which is present, we have to highlight 6 with a solid circle. And we have all the points in between 3 and 6 with x greater than 3, lesser than 6, highlighted by this solid line connecting 3 and 6, with 3 not included in the solution and 6 included in the solution. This is the solution of representation of the solution in the number line for P. Okay, this. Now for Q. Q is represented as x with minus 1 lesser than equal to 3 plus 4x lesser than 23 with x belonging to the set of integers. Okay, now this inequation, again, it also has two parts. Okay, so the first part is minus 1 lesser than equal to 4x plus 3, and the second part is 4x plus 3 is lesser than 23. So we have to solve them individually. So here we have, if we take this 3 to the other side, we will have minus 1 minus 3 is lesser than equal to 4x. Okay, so that implies minus 4 is lesser than equal to 4x. So we have studied in the rules of handling inequations that if we change the sign on both sides of the inequation, the sign of inequality reverses. So here suppose we change minus 4 to 4, and well, there is no need of that. We can simply do another thing. Okay, instead of going through all this, we can simply do it. Minus 4 is lesser than equal to 4x, so we can do 4x is greater than equal to minus 4. Okay, that implies if we divide both sides by 4, we will have x greater than equal to minus 1. Okay, this, or you can represent it as minus 1 less than equal to x. Either ways, it's the same thing. Something is greater than that, it means it is lesser than. The reverse is also correct. Okay, so this is the first part of the solution. Then we have 4x plus 3 lesser than 23. So here we'll take this 3 to the RHS, it becomes minus. So 4x is lesser than 23 minus 3. That implies 4x is lesser than 20. Dividing both sides by the same positive number, that is plus 4, we have x is lesser than 5. Okay, so in both the cases, x belongs to the set of integers. So here we have q represented as minus 1 lesser than equal to x lesser than 5 with x belonging to the set of integers. Now here, if we plot the solution on the number line, we'll have okay, so x is greater than or equal to minus 1 but lesser than 5. So minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. So here make a mental note that this is integers we are talking about, it's not real numbers, so it will be different. So distinct integers. So minus 1 lesser than equal to x. So minus 1 will be included. Okay, x is greater than equal to minus 1, so minus 1 will be included. 0 will be included. 1 will be included. 2 will be included. 3 will be included. X is lesser than 5. Lesser than 5. So 5 is not part of the solution, but 4 will be part of the solution. So this is the solution on the number line for this condition. Minus 1 lesser than equal to x lesser than 5. Okay, distinct integers, not real numbers. So there is no solid line here. Then we have to find the common values for P and Q. This is P and this is Q. So if you see, intersection means common, or and what we are talking about, and union. Okay, this is intersection. Set theory, this is intersection, this is union. Intersection basically is and. operation, and union means OR operation, which we have discussed. So when we will discuss set theory, we will discuss all of these things in detail. For now you understand that we have to find the common overlapping or intersecting values of P and Q. So P intersection Q will be, the common values are, here there is 4, okay, there is 4, and here also there is 4 included in the solution. So the only value, the only element which is common to both P and Q, that is 4. So the solution is, the intersection solution P intersection Q is 4, nothing else. Okay, nothing else, because decimal values, fractional values are not allowed, because here it is integers, here it is real numbers, but P is for real numbers, Q is for integers. So only 4 is the value which is common to both the sets P and Q. Okay, both the solution sets. This is the intersection solution. Okay.